Hello students, hopefully you must be enjoying whatever all we have discussed in kinematics. So this is being the last part of this particular topic. We have already understood about the relative motion between two different objects. So the two objects can either be moving or it can be at rest. Either of them can be at rest. We are now going to generalize that to the concept of curvilinear motion. What does curvilinear motion actually stand for? When the object is moving in a curved path, for instance, let's take the case of a car moving in a curved road. When the car is moving in a curved road, obviously, even though its speed may be constant, it may be moving at a constant rate, but its direction is changing at every instant. Since its direction is changing at every instant, so therefore that velocity is changing, and therefore there is a force acting on an object. So taking the cue from this, we'll understand about curvilinear motion in this last part.
So what do we understand about the other type of motions? Let's say talk about the curvilinear motion. So talk about the curvilinear motion when the particle is moving along a curve and not in a straight line. That is what is meant by curvilinear motion. So its velocity is changing at every instant of time because it is moving. So therefore it is going to be an accelerated motion. In this case, what we are going to say that the position vector of the particle at time t is going to be defined by a vector with an origin O. So if I say that this is the vector, this is the origin. So at every instant of time, if I say r is the position vector of the point P, r prime is going to be the position vector of point P prime, and so on. So as a result, what we are going to say is that it's going to be the position occupied by the particle at any instant of time. So if I say that, if I consider that the particle occupies a position P, which is given by some displacement r at time t, and P prime is given by r prime, in that case the velocity of the particle P can be given by delta r by delta t, which is nothing but in the limit delta t equals to 0, so this is going to be equals to dr by dt, which is nothing but the instantaneous velocity. In similar manner, we can say that delta s basically is not the displacement, it is the distance. So it is starting from this particular point, let's say. So from here to here, how much is the distance it covers? So this is how we find out the instantaneous speed. As you can see, this is with an arrow, so it's a velocity. So it is going to depend with respect to the position vector from the origin, mind you.
So when we talk about this,
So
says
now
the
we come
amount
to
of
the
charge and
last
the
part.
energy that is
Basically,
stored
here
is going to
we'll
be
be
given by
discussing
this.
about
And how
what
do we
exactly
get
is
that?
an electric
We know
dipole.
that Q
As
equals
I
to C
mentioned
into V.
at the end of the last
Further,